Okay, this is the last one I want to do. And this is not the easiest of the ones of its kind. The easiest one is this one right here because it has a positive 1 in front of the x squared. This one's the easiest one, but I want to do this one. Okay, everybody take out your formula charts. I want you guys to look at 2 formulas that you need to make sure you know. Boom! There you go. So these are the formulas you guys need to know. Okay? Now, this is what you're starting with. And then once you get whatever it is you're looking at to look like these, you use this side to get your answer. Okay? Now, there's a quick shortcut that you can see really fast. Is this answer going to be an arc sine or sine inverse? Or is this answer going to be arc tan or tan inverse? You can tell really quick. Here, watch. Look at these. Will this be an arc sine or arc tangent? This one will be sine. Will this one be arc sine or arc tangent? Arc tangent. Now why? How do you guys know this so fast? Will this be arc tan or arc sine? Arc tan. Why? How do you know this so fast? There's no square root. Okay, the square root 1 has a sine, is the sine inverse. So we're not going to be using this guy, all right, for this one. We know this answer is not right, and we know this answer is not right. Okay, it's not the arc sine. It's not the sine inverse. So now our goal is to make this thing look like this. Well, actually, let's use academic language. We're going to make this integrand look like this integrand. Okay, now let me help you out really quick. I don't know why, but this really helps some students. I'm not going to say x squared right here. I'm going to say something squared. And so that something goes right here where this x is. I want to say something. Okay, so we need this guy to say 1 over a squared plus something squared. Now the trick is that something is the thing that has the x. All right, the a does not have the x, and that something is going to be on top of the a when we're done. So let's first just try to manipulate this to make it look like that. Now the way we manipulate this is we do something called completing the square. Look at these 2 terms, these first 2 terms, 5x squared and negative 2x or 20x. The first thing you got to do is make that number in front of the x squared into a 1. So what we're going to do is we're going to factor out the 5. Then we'll have x squared minus 4x. We got 4 because we took the 5 out of the 20. And then you're going to have a plus blank. The plus blank is what makes it into a perfect squared polynomial. But since you added something, you need to make sure you take it away. So we need to also minus that out. We need to subtract something. If we're going to add something, we have to subtract something. Now, this one's tricky because this something is multiplied by 5. And so one thing to do to make sure you don't mess that up is you write a 5 right here so you can make sure that you multiply it by 5. Okay? So this is going to be our new integrand. Now I need to take a pause and go back to Algebra 2 to remind you guys of what a perfect square polynomial is. Okay, here's the first example. This guy is a perfect square polynomial. Why? Because if you factor it, you would get x plus 5 to the second power. Okay, here's another example. X squared minus 8x plus 16. Do you guys know what that would equal if you factor it?
X minus 4.
Yeah, x minus 4. Oh. So this is a perfect square. This is a perfect square. We want it to look like this because remember, we want something squared, right? We want it to look like this. So we're trying to get the something squared. So here, let me see if I can give you guys another one and you guys tell me what I have to add to it to make it a perfect square trinomial. What would be my blank for this one so that it is a perfect square trinomial? Do you guys know what you would add right there? 49. Very nice. How'd you guys get that? Actually, tell your neighbor how we got the 49. Do you guys remember b divided by 2 squared? Do you guys remember that? Nobody? No? Now, the b is your x term. And so what we do is we take the 14 divided by 2 and square it. That's how we get the 49. So do you guys know what I'm going to put right here?
49.
No. What is this divided by 2 squared? Oh, my goodness. Yes, it's 4. And so then I put a 4 over here. But this is not really a 4. What is it? It's a 20. That's right. Okay, so let's simplify this now that we completed the square. Back to doing calculus stuff. So we have 5 times x minus 2 squared, because if we factor this, that's what we would get. And then we have a plus, what is that? 80. Plus 80. And then we're almost done. Okay. Now, can I factor out a scalar? Because if we can, it'll make things nicer. Please factor out a scalar. What is my scalar I can take out? What can I take out of the denominator? We have 2 terms. We have this term and we have this term. What can I take out of the denominator? Tell your neighbor if you know. Go on, tell your neighbor. What can I take out of the denominator? I could take a 5 out, right? I take a 5 out. So if I put a 1 over 5 right here, this 5 would be gone, and what would the 80 become? What's the 80? What? 16. 16? Yeah, you're right. It's 16. Hey, that's nice. Do you guys see that? Do we have something squared, and do we have a perfect square?
Yeah.
That's 16, right? Okay, so this is a 16. Actually, let's just erase this and put the 16 so it's all pretty and stuff. Okay. So this is my integral sign, and now it's 16. Hey, we have an a squared, and we have a something squared. So once we have that, we can identify the a, and we can identify the something. What is the a? It is 4. What is my something? X minus 2. So you're just going to take those and plug them in. Let's do it. So we have an A, which is 4. And then, this is kind of nasty right here. So we're going to say X minus 2 over 4. And then I'm forgetting one thing. Do you guys know what it is? My scalar. What's my scalar? I'm multiplying by what? 1/5. And so if I multiply this out, I have 2 terms. I have this term and I have this term. So I have to multiply the 1/5 to each term. And so I get 1. Actually, here, let me erase some stuff. I get 1 over 20. 1 over 20. Dang it. And I like writing tangent inverse because it's less letters. And then x minus 2 over 4. Plus, and if I multiply 1/5 times a c, that'll just be a different c, right? In fact, I should say this is c sub 1 and this is c sub 2, but you don't need it, okay? But there you go. There's your answer. So these problems right here, you still have to complete squares. This one you would have to factor out a -1. And the square root, don't let it scare you. It's just going to sit there and you're going to work inside here. Remember, you're trying to make this look like one of the formulas. This one, you would want it to look like a squared minus something squared. And this one over here, this is your easiest one. You don't have to factor anything out, but you still have to complete the square.